Hey Boxers, in this video we're going to check out another smart asset. We're going to check out Rotation Cube. So I'm going to go over here to my fly template here, and I'm going to start off with fly. And we'll take a closer look at the smart asset Rotation Cube and see how it works. So I'll double click on my 3D world here, and then I'm going to zoom out and rotate around so you can see a little bit better. I'm going to delete this point just for this example. I'm going to go over here to my asset library and go over here to assets. And then I'm going to scroll down and I'm going to find Rotation Cube here, and you can see an awesome little preview that's happening over here in the upper right hand corner, so you can already get an idea of what it's going to look like and how it's going to perform. It's pretty awesome. So I'm going to just click add to library so I can add it here to my objects menu. So I'm going to click on asset library again, and I'm going to take my rotation cube and I'm going to bring it out here into my scene. So for right now, I just kind of want to demonstrate how this rotation cube works and what you can expect from it when you use it in a scene. So the way that this is structured is very much like you would find in a math class. So this red axis here, this is going to be your x-axis. This green arrow, or this green axis, is going to be your y-axis, and then this blue one here is going to be your z. So over here, when you go and you check out the end rotation, this is where your cube is going to rotate to. So it's going to start off with the original rotation that you put it in within the scene. So it's going to start just how you have it, and then the end rotation is determined by what value you put in these text boxes. So for right now, there's a rotation of the x-axis. So let me go ahead and first I'm going to scale this down a little bit so it's a little bit easier to see for demonstrating. I think you'll find that this is a little bit better. So for right now, we're going to rotate around the x-axis. So what you can expect to happen is it's going to flip upwards, or you can see that it's going to just flatten out a little bit. So let me go ahead and show you what that looks like real fast so you can get an idea. Now I'm going to double click on my actor real fast, and I'm going to take my move node and I'm going to pin it so that in the 3D world I can reference it and it'll be a little bit faster. So I'm going to click on my actor, and then I'm going to change the speed. Instead of -20, that's a little bit fast for this demonstration, I'm going to do it about -4. Okay, so now you should see that as it comes closer to this, it's going to rotate. The last thing that we need to switch up is the distance. So I'll go ahead and do a distance of about 300 pixels or so, and let's go ahead and play this and see what this looks like. Okay, great. So you can see here that it flips up or flips down, however you want to look at it, but it rotates around the x-axis, and it does so at 90 degrees. Now, if I wanted to rotate it around the y-axis and make it look like a door is flipping open, then I would just make this be 0 in the x direction, and I'll add 90 degrees to the end rotation in the y direction. So these boxes are x, y, and z over here. So now it's going to rotate and spin along this y-axis, so you can expect it to look like a door is opening up. So let's go ahead and take a look at that real fast. All right, it looks like a revolving door just spinning on its y-axis. So I'll exit out of the preview again. And so the last one is rotating around the z-axis. So I'll go ahead and take it off the y, and I'll do a 90 rotation of the z-axis. And so what you're going to see now is it's going to spin. So this should come up to the top, this will go to the bottom, or vice versa. This side might go up to the top, but it's going to spin along this z-axis right here. So let's go ahead and preview that so you get an idea. So it should spin. Perfect. Okay, great. So that's what that looks like when you do a spin of the z-axis. Or let's say you want to spin in 2 different directions. Then you can do so by putting different values in for multiple text boxes. So for this one, I'm going to put 90 degrees in the y and in the z. So it's going to spin this way, and it's also going to spin on the y-axis as well. So let's take a quick look at what that looks like. So I'm going to hit preview again. Should spin up and over. Awesome. So it's perfect. That's exactly what we want. So I'm going to exit out my preview again. And you can find a lot of really cool uses for this in your game. And so this is a really awesome smart asset to add into your game. It's definitely something that you can find some creative uses for. So now let's go ahead and let's double click on the rotation cube and let's check out the rotation cube's node map. So first thing I want to do is I want to check out the rotation animation. So I'm going to hit this little marker here. So this is going to open up the JavaScript editor. And so I want to quickly just walk you through all of these functions here. It's got our 3 basic functions in it, update and signal, and it's got an extra function here for the ease in and out and a couple variables at the top. But let me just quickly walk you through everything that's going on here. It's going to be a little bit more of a technical explanation. Okay, so up here, we just have our variables being called. So we have a variable that is a counter, and that one starts off at 0. We have 3 uninitialized variables here, speed, start, and end. They're not given any value. They're just a straight up variable here. And then we also have a variable enabled that starts off as false. Before we go into the ease in and out cubic, this is probably the most difficult part to understand within this, and so I'm going to go over this last. But for right now, let's just go over these 3 functions real quick, and then I'll go over the ease in and out cubic function. For the function init, so this is the starting off, this is the initialization. We start off by making start equal to this entity's rotation. All right, so we've captured the rotation of the rotation cube. And so we've got that starting off, and then we've added some attributes over here, the end rotation and the speed, which you can find over here. And so those are really, really simple. You have the X, Y, and Z rotation and a speed for how fast you want this rotation to be. So let me explain real fast how the speed works. So if you put 1 in for the speed, that means that the rotation is going to happen within 1 second. It's going to take 1 second for the rotation to happen. If you put in 2 for the rotation there, it's going to happen in half the time. So it's going to happen in half a second. And so the greater the speed, the faster the rotation occurs. Okay, but it starts off with a 1 second rotation if you put in a 1 in there. Okay, so the next is the update. Now remember the update fires off 60 times per second because it's 60 frames per second, and it's passed in dt, which is a value for delta time. Okay, and this value here is 1/60th. So it gets passed in 1/60th and 1/60th over and over and over again until it's complete, and it does that 60 times per second. Okay, so the start of this function, it checks to see, is this function enabled, okay? Is the node enabled, and can we do something with it? And if it's not enabled, which this is the little exclamation mark and the underscore here, so the exclamation mark means not, and then this underscore enabled is just the name of the variable here. So it checks to see if this is not enabled, then just return and let's exit out of here and let's not do this. If it's not enabled, then don't do any of this. Okay, and I'll talk about this in a little bit right here, but the last thing I want to say is this function signal here. This is where you get the enabled value turning to true. Okay, so what's going to happen here is this wake up node, it's going to check to see if the character is a certain distance away from the rotation cube, and if it's the right rotation, then it's going to say, okay, let's enable this rotation animation. So you can see here it should have an emit signal, which is awake is set to true, and so this is awake is set to true, and it sends the signal that the rotation needs to go. And so the function signal takes in the value that's being passed to it, and so if the wake up value is true, then it's finally going to be enabled, and then we can go ahead and see this happen. And this is really right here, this section, this little if loop, this right here, this is what accounts for the animation itself. So the first thing to check is if it's enabled. Okay, then let's go ahead and continue. And if so, first it checks to see, okay, what is the counter? And if the counter is less than 0, then we're going to start doing this animation. And we already know that the counter is set to 0 to start off with, so it's going to start off at 0, and then it's going to continue to go higher and higher and higher up until it reaches 1, and it's going to keep going through the process of doing the animation until it reaches 1, and then it's going to stop, and it's going to exit out of here, and then the animation is completed. So the first thing is it creates this anim variable here, and it's set equal to the ease in and out cubic function up here, and it's passed in the counter value. So it's passed in a counter value of 0 to start off with. And so then what this does is it passes in a 0 here for the t. So now the counter has become t, and so ease in and out cubic is passed in a 0. Okay, and then this first statement here is it divides 0 by a half, and as long as t is less than 0, then it returns 1/2 t times t times t. So what this does right here, this example is an example of exponential growth. Okay, the second part here is an example of exponential decay. So I'm going to show you real quick on a graph what this looks like. And what this does is it creates a nice smooth animation that looks really fluid in your preview. So I'll show you the graph right now. And you can see here that this bottom part is an exponential growth, and then at the halfway mark it starts to decay and it smooths out. And so this looks really, really nice. Okay, now let's keep talking about this function here. So now that we've created this animation and it's figured out whether or not it is in the exponential growth or at the point of exponential decay, and that tells you where you're at in your animation, you now set x, y, and z equal to the start animation point, and then you're also going to have an end animation point. So let's take a look at just x for right now. Okay, so it says let x equal the start value. So the start value, if you remember, is equal to the original entity's rotation. Okay, so it stores that value in as the rotation. And so to start off here, the anim, for the very first time it's being passed in, okay, you're going to pass in 0 because the counter is equal to 0. So it passes it into the ease and out cubic function here, and this ends up just being 0 divided by a half, which is 0, and then if t is less than 1, which it is, it's going to return 1/2 times 0 times 0. So you end up just starting off with your 0 animation. And what this does is this accounts, basically what it's accounting for is the entire animation. It's your starting point, okay? And then what it's going to add is the animation as it takes place piece by piece. So as 1 is minusing the animation here, this value is going to become less and less and less until there is no more start animation happening. You have nothing left of the start animation, and you're going towards just having what is in your end animation here, your end rotation. That value is being passed in here for the underscore end dot x, and then it's multiplied by the animation. That tells the speed or just where it's at in the animation. Okay, and it's the same thing for the y coordinate and the z rotation. And then what it does is this entity it sets the rotation. Now the function set rotation sets the x, y, and z according to where it's at in the animation. And this happens 60 times in a second. So it's constantly checking boom, 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 boom. And then it's going to smooth out. And then at the very end of this function, the counter is then updated. So plus equals means it's adding to the value of whatever delta t times the speed. So this is going to be 1/60th times the speed, and it's going to just keep adding and adding and adding until the counter eventually equals 1. And then once the counter equals 1, it's never going to perform this loop, because it only performs this loop if the counter is less than 0, or I'm sorry, if the counter is less than 1. So if it equals 1, then it does not do this, and then your animation is complete. This is basically the breakdown for the code here for the logic, and it's very, very simple to edit this logic around if you like. So again, let's check out. So this is the ease in and out. So this is a nice curve. It's a much smoother animation. Let's take a look at what it looks like without this ease in and out cubic animation. Okay, so one last time, let's take a look at what it looks like with it. So you can see here, kind of a nice smooth animation. And then let's take a look at what if I just got rid of the ease in and out cubic, and I just let the animation equal the counter. Okay, it'll still work, but what's going to happen here is this is going to be more of a linear animation. So this is like on a graph of value over time. This is going to just be very, very straight on. It's going to be just a straight line and linear. It's not going to have that smooth curve. So let's go ahead and run it now with the animation just equaling the counter. Let's see what the difference is. Okay, see how it kind of is, it's just very, very straightforward. It's the same speed. It doesn't have that kind of like the whip around. Let's go ahead and let's change this back. So I just added the ease in and out, cube it back, and let's see it one more time so you can see the difference. See how it kind of has a nice, like a more of a natural rotation, and it looks a little bit nicer. So I'm going to exit out of the preview here. So you can change it to whichever way you want. If you like the effect of the ease in and out, then please go with that. If you like the more of the linear and just it's very stagnant and straight, it performs the rotation at the exact same speed throughout, then if you like that, then go ahead and get rid of this ease in and out cubic function. Just make the anim equal the counter, and you can probably comment out this function or just leave it. It doesn't really matter. It's never going to be fired off because you get rid of the ease in and out cubic function here. So I hope you thought this video was useful. This is a kind of a more in-depth look at the code that's going on behind the nodes here. So if you want to edit it or change things, you can totally do that. In the upcoming videos, we're going to go over a much more simpler flow of how you can start and create your game start to finish, and it'll be a lot more easier for all of you non-coders out there. But just in case you wanted to take a look at what's going on behind the scenes, I wanted to kind of briefly go over what's happening here. All right, boxers, thank you so much for watching this video, and keep on boxing.